You'll recall from an earlier episode that computers work through a four-stage process to do anything: input, processing, output, and storage. That second stage, processing, requires a bunch of parts working together, such as the CPU, memory, and the support chips on the motherboard. Plus, it requires an operating system to tie everything together. The CPU does the main number crunching. That's the basis for processing. But it turns out that CPUs have almost no memory. Think people here. Your brain can process information you take in from your input devices, your senses of sight, smell, touch, psychic awareness, and the like. But what happens when you need to process information that you learned about the day before? You rely on your memory, right? A CPU doesn't have that kind of memory at all. It needs a separate memory piece that stores remembered information. That's the job of random access memory, or RAM. This episode looks at three aspects of RAM: function, capacity, and adding more. RAM holds all active programming on a computer. That includes the operating system and running applications and data. This is important because RAM has a notable feature. RAM stores data, but only temporarily. If the power goes out, all the information stored in RAM goes away. That's not a big deal for the operating system and applications. The computer stores copies of them in long-term storage, like on a hard drive. But that paper you were working on but didn't save? Goodbye if you suddenly lose power. Just remember to save your work, and that feature of RAM won't bite you. The amount of usable RAM in a computer is called system memory. The total capacity of system memory puts a hard limit on how much stuff a computing device can work on at one time. If you try to do too much, modern computing devices won't die, they just slow down. If you want to see this in action, just start opening programs on a desktop or laptop computer. Eventually, you'll hit the system memory capacity and the computer will get sluggish. All computing devices today require RAM. On smaller devices, such as smartphones, the manufacturers sometimes hide the RAM. My iPhone has RAM, but you can't tell using any of the default apps. Here's an Android smartphone that clearly shows the RAM. In the Settings app, Device section, there's a spot called Memory. And there it is, 2.2 gigabytes. Why hide the RAM on some devices? You can't change it, I guess, so it doesn't really matter as long as the device works well. On bigger computers, you can upgrade the RAM, so that's a different story. It's easy to see and discover the RAM both looking at the operating system and physically opening the box. Here's my computer running Windows 10. The system settings will show the system memory. In Windows 10, press the Start key and click on the Settings app. In Settings, click System. Then select About to open the screen. So, see here? Installed RAM 16 GB, 4 gigabytes. The more, the merrier. Let's get a little geeky. Here's a motherboard outside of the case. The CPU is under the heatsink and fan assembly. Go a little to the side and you can see a stick snapped into the motherboard. That's the RAM. Many computers enable you, or a tech, to add additional RAM to increase the overall memory capacity. You can also replace the installed RAM with bigger capacity RAM sticks to get the same result. This almost always dramatically improves the overall performance of a computer. You can upgrade most Windows workstations and many laptops. Apple computers are mixed. You can upgrade a lot of iMacs, for example, but not the sleek portables like the MacBook Air. One final note, and we'll leave RAM behind. Remember when I described system memory as the amount of usable RAM installed? Some systems enable you to add more RAM than the current CPU or operating system can handle. A 32-bit operating system, like some versions of Windows, can only handle up to 4 gigabytes of RAM. Beyond that, you need a 64-bit operating system. Let's wrap this up. All computing devices use RAM for system memory. System memory holds all the active data and programming. Overall capacity of system memory is measured in gigabytes and determines how much a system can do at one time. 32-bit systems are limited to 4 gigabytes of system memory. 64-bit systems can handle tons more RAM.